Hello there, friends and neighbors. I'm going to show you now how to do Real Data Homework 3. This is an example with data from a particular quarter. In subsequent quarters, the questions will not be exactly the same, and the numbers will definitely not be the same. Those sorts of things, of course, are going to vary from quarter to quarter because the data are different every quarter. However, the steps we take are exactly the same steps that you need to take in order to analyze the data as required by this assignment. So the first thing we need to do is go to the assignment itself. You will find it in the Week 2 folder. So going down to Week 2, here it is. That's where we find Unit 3. So here's Unit 3, Descriptive Statistics. I'm scrolling down to get to the Real Data Homework 3, which is here. Okay. And I don't have any group members. I'm just going to be myself. But I guess I could if I wanted. Alright, so here I am starting the assignment, and the first thing it has is the data from Stat Survey, which we need to download and save. So right click, Save Link As, and I already have it saved, so I'm not actually going to save it. But you need to save it someplace that you can find it again. I have a folder called Data where I save the data. Save, and of course I've already got it, so cancel. Okay. I've also got an example here of a PDF that shows you all the steps that you will need in order to do this assignment. And lastly, since this is our first experience using R and R Commander, the statistical package that we need, I've got instructional videos that show you how to either access R using a VMware client so that you can access the Centralia College Virtual Desktop and use R from there. Once you get there, I've got a video showing you how to install R Commander and EasyR plugin so that they always run easily on your computer, on your virtual computer. Or if you prefer to install it on your own computer, I've got a video here that shows you how to do that. This process will take maybe a half an hour, and once you've got it set up, you'll be set up for the rest of the quarter. This spot here is for this video here. I'm going to have a link to this video once I've created it. I haven't created it yet, so the link doesn't exist yet, but it will be there. Okay, so next I'm going to read the assignment. First, it asks me to use R to make a histogram for height with the data. So the first thing I'm going to do, I've downloaded the data file, and now I need to load up R. I have R set to automatically load R Commander and EasyR, so I don't need to type the instructions. If you don't have it set to automatically load, then you will need to type the following commands. Library RCMDR. Then you hit enter and it will pull up R Commander. Once you get to R Commander, you need to go to Tools, Load R Commander Plugins, and then you choose the EasyR plugin. And you click OK, and it will reload, and that's how you access it. But again, I've got it set to automatically load mine, and I have in my instructional video shown you how you can make it automatically load as well. Now that it's here, the next thing I need to do is import the data file. File, import data, and it is a text file. In this class we use .csv, that is comma separated value files. They are text files. So read text data from file, clipboard, or URL. Click OK. Maybe give it a cool name, or maybe not. You don't actually have to give it a new name. Click OK. Go find wherever you saved the file. I saved it here. Here's the data file. I've got it now opened. And this is what it looks like when you have your data file opened with R Commander and EasyR. Now, the assignment asks me to create a histogram for height. So I go Graphs and Tables, Histogram, choose the variable height. Then you click OK. Once you've done that, it spits out the file, and you can right-click on it. So, hang on a second. Here's the file. Okay, come on. Right-click on it, save as, give it a useful name so that you can find it again. I just called it, because I've already done this, Real Data Homework 3, 1a histogram. Now, that means I'm ready to actually upload it. I've saved it, and now I come to the assignment, and the first question says choose file. I'm going to go to where I have that file saved. Lessons. Okay, and here's the file. Say open, and I upload it, and that's how I do it. Next, go to question 2. Oh, I'm not actually going to save it, so I leave. But if you wanted to actually get credit for it, you would have to click submit. Now, use R to make a box plot for height. Identify outliers using the 1.5 IQR rule. Okay, let's go back to R. Where's R? Oh, here it is. Okay. Graphs and tables. Box plot. Height. And now the important part here, there are various definitions of the whisker range. I can do 1090 percentiles, 595 percentile, min-max, or, as required by the assignment, the 1.5 IQR rule, and that's what I'm going to use. Then I click OK, and it gives me the graph. Okay. And again, I've already created it. It looks like this. So you right-click, save as. I did all this before, of course. I did this before creating the video. So now I've got the file. Close that because I don't need it anymore because I've already saved it. Then I come back to the assignment page and I click choose file. I go find the file, click open, and upload it, and I would click submit if I were trying to actually complete this. But I'm not, so I'm going to leave. And I've gone back to question 1. Now I need to go to question 3. Now discuss the shape, center, and spread of this distribution. I'm going to go pull up my graph so we can actually look at them. Here's the histogram, here's the box plot. So, okay. Is it unimodal or multimodal? Well, this appears to be unimodal. There's one center of mass right here, this lump in the middle. So it appears to be unimodal. Do there appear to be any outliers? Well, I see what appears to be an outlier here. An easier way to identify outliers is to look at the box plot, and again, I see an outlier here clearly, this person who said that their height was 5 inches. It's not accurate. I don't think it's realistic that anybody was 5 inches, but far be it from me to alter someone's data. In any event, I do see one clear outlier. So yes, there appears to be one or a few outliers. After removing any possible outliers, is the graph skewed right, skewed left, or symmetric? If you look at the box plot, all the quartiles are reasonably close to being equal. And again, if we look here, it looks like it might be skewed left, but I think it's reasonably symmetric. I don't know, it's kind of open to debate. It's always open to debate. I think I would argue that this is reasonably symmetric. If you wanted to argue with me, you could say, if anything appears to be ambiguous, you could say, well, sir, the histogram looks sort of skewed left, but the box plot looks pretty symmetric. So that's fine, and you can make any argument you want out of that. You click submit so that you get credit for it. I, of course, am not going to click submit. Next question. So shape, center, spread. Now let's look at the center. Find the center. Okay, how do we get the mean and median? Well, because of the possible skew and outliers, I think I probably trust the median. Let's get those values, and it says to round to 1 decimal place. So here's how you get the descriptive statistics for the quantitative variable. Statistical analysis. Continuous variable, quantitative variables are always treated as continuous. Categorical variables are inherently discrete. So I'm going to go to continuous variables, numerical summaries, and height is the variable. And then I click OK. From this I get the mean standard deviation, the minimum, the first quartile, the median, third quartile, and the maximum. I get the 5-number summary, the sample size, the mean, and the standard deviation, all in one fell swoop. The question asked for me to round the mean to 1 decimal, so that 65.66 becomes 65.7. Okay, so 65.7. Is that right? 65.7. Oops. Hey. Okay. Whereas the median over here is 66. Which do I trust? I trust the median because of the skew and outliers. When we have skew or outliers, we don't trust the mean. We have to use the median. Okay. And you would click Submit if you wanted credit for this question. I, of course, don't want credit, so click Next Question. Find the spread from the range, the IQR, and the sample standard deviation. Well, the range is the maximum minus the minimum. Maximum is 77. The minimum is 5.4. So let's figure out what that is by just using a simple calculator. 77 minus 5.4. Is that right? Okay.